Decimal string. Oh, I didn't intend like that. All right, class. Okay, decimal to binary. So, it should be up in the.
Yes, sir.
Okay. Let's zoom in. I can see the board. You'll be on YouTube, but I don't do nothing with it, but for educational purposes. All right. Okay. So we have this number 240 in decimal. All right. We want to convert it to binary. Miss James just wrote down the what? Placement table, right? What's the first rule? You take that number and what?
Second to last, whatever.
You find the value that's the closest, the highest value that's less than or equal to 240. What is that?
128.
All right, so what you gonna do in that column?
Put a 1.
You mark that 1, okay? Now, you mark that 1, so now you're gonna have to deduct what?
128.
128 from
240.
240.
Gives you 112. You can use calculator for this?
Yeah, could use a basic calculator, not a scientific calculator, Miss Sue, right? All right. Now we get 112. Now, as long as we didn't get to 0, we still have to do what?
Subtract.
Subtract. We have to go back through the loop. So find the value, right, of the highest value that is less than or equal to 112, which is
64.
64. So you do what? Put a 1 in that column and then subtract 64 from 112. You can get what? 12 minus 4 is 8, right? And 10 minus 4, 10 minus 6 is what? All right. Oh yeah, 12 minus 4 is 8. Yeah. All right. Okay, now, once we do that, did we get to 0? No, so we continue on, we repeat. Find the highest value, 1, and then what? Subtract what?
32.
32 from 48. And we get what? 16. Okay. Find the highest value that's less than or equal to. So you put a what? A 1, and then what? 16 minus, okay, and 0. Right? Now we have 0, but we only have 1, 1, 1. But what we need to do to make our number the correct number?
Fill in the zeros.
Fill in the zeros, right? 0, 0, 0, 0. Now rewrite that. 240 in base 10 is equal to what in base 2? Base 10. Right. Is equal to 1, 1, 1, 1, 0, 0, 0, 0 in base 2. All right? So that's the process, class. Anybody have questions? And like I said, you could take a larger number, you just would have to what? Expand your what? Placement table, correct?
Yeah.
All right?
And that was for decimal to binary?
Right, because look, you got it on the board, decimal to binary. We have a decimal value, we need to find out what's its binary equivalent, so we go through that process.
And then for octal placement, that's with the 3.
Well, first of all, octal is what name? What's the octagon?
It's 8.
Oh, okay, octal,
Yeah.
right?
8.
So, base 8.
Yeah.
Okay, what's the digits in octal?
7.
0
0
through
7.
7. Right, those are the valid digits. So, in octal, let's take that number that you just converted. She converted 240 into a binary digit, correct? Let's take that binary digit and make it, turn it into, convert it to an octal, all right? So, how will we do that?
Group it in 3s.
Do what now?
Group it into 3s.
But there's one little catch that you gotta follow. Starting from
Right to left.
the right, going to the left, We're gonna group it by threes. Right, remember? Right, just add a zero. That doesn't change the value of that number, correct? Then you just solve using the binary table. Look right here, you can do 2 to the 0, 2 to the 1, 2 squared, right? So,
Wait, so you should add 0 in front of the number?
well, sometimes a person may get confused as to the grouping of threes. So you just put the 0 so that you wouldn't be confused. You understand? Because if I write the number 10,000, right? But I wanted to represent it in threes, digits. I could put a 0 in front. I'm not changing the value of what? 10,000, correct? So that's somewhat what this is. If you told somebody to divide a number by 3, starting from the right going to the left, just put that 0 at the beginning if you have some left over. If you got 1 left over, 2 zeros. If you got 2 numbers, just put.
Quiz, right?
Huh?
That's not on the quiz, right?
This will be on the quiz. The binary to decimal, decimal to binary. All right. So yes, what you got, Miss?
So I separated it into
Threes.
and then I did the.
Solve it. So what? What you got?
The 1, so that's 3.
All right. 2 plus 1 is 3.
Then 0, and that's 6.
4 plus 2 is 6.
And then all 3 are 0.
Zeros. So what she did, class, and so rewrite at the end of this. At the end of 1111000 in base 2 is equal to what in octal?
Oh, 3.
Just add that, add it at the end of this.
Oh, okay.
That equals
360. Base 8.
in base 8. What did she do, class? She took 0, 1, 1. She took 0, 1, 1 and placed it under here. Wherever there's a 1, you just add those columns. 2 plus 1, you got 3. 1, 1, 0. 4 plus 2, she got 6. 0. 0, 0, 0, it's zeros. So everybody understood how she got 3, 6, 0, right? Now, this is what I want Miss James to do. Take 360 in base 8 and convert it to decimal.
So I might have to add.
Right. Not that. We dealing in base 8. We taking an octal number and want to convert it to decimal. So we're gonna need our what? We're gonna need our octal placement table. So you could come over here and create your octal table. How many digits you have?
Oh, so then I get.
No, how many digits you have in octal?
3.
So you're gonna just need them 3 columns. Yeah, just 8 to the 0, 8 to the 1, 8 squared.
Oh.
Right. Yeah, that's your binary. Right, correct. So you understand? That's one of the keys. If I'm dealing with octal, my octal table. Now do your values. Right. Do your values. 8 to the 0. No.
Oh, wait, sorry, 1.
Right. Anything to the 0 power is 1. 8 to the 1 is 8. 64.
Oh.
Right. Yeah, 64. 8 squared.
Yeah.
Now, class, remember what we did when I gave you a number like 123. If we broke that down in base 10, that would be what? 100, or 1 times 100, right? Plus 2 times 10, plus 3 times 1, correct? So in octal, we're gonna have to take 360, place it under the placement table, take it, put it under there, put 360 under that. Under each column.
Oh, okay. Oh.
So to get the decimal value of that octal number, we're gonna say 64 times 3 plus 8 times 6 plus 1 times 0.
Oh, this is when we can multiply it all in.
Right, because you're going back to decimal. What, 4 times 12, 3 times 18, and 30. All right, 42 plus 0. All right,
So then,
wait. 8 times 5 is 40, right? 8 times 6 is 46.
okay.
Wait, what's 8
I thought it
times
was,
6?
I thought it was 48.
48, yeah, that was a 48.
Okay.
You're right. All right, so now add those up. What's that equal to? So now what? 240 in base 10 is equal to what in binary? 1 1 1 1 0 0 0 0, which is equal to what in octal?
360.
Which is equal to what back in base 10? 240.
Okay.
So, and put that equal to at the end of that.
And is that, that's.
10, that's back to base 10.
Okay.
So, you see what we did? We took a number in one base, we converted it in all these other bases, and eventually converted it back to the original base. And got the what? Same answer. Got it?
Yeah.
So, now, we kind of done it, but we can still do it. Let's convert a binary number to decimal. Mr. Calkins, give her a 5-digit binary number.
Should I erase something?
Don't, you can leave it up. Give her, just right at the bottom there. A 5-digit binary
Ones
number.
and zeros.
Yeah, a binary.
10101.
In base 2. In base 2 is equal to what in base 10? Put equal and a blank line in 10. Blank line, and 10. 10 at the bottom. All right. So how will we take this binary digit or number and convert it to base 10? Class? How will we do that?
It converted to base 10. Do we convert it to something else before we convert it to base 10?
Now, let me give you a hint. When we converted base 8 to base 10, we had to put it in the placement table and multiply. When we're going to convert base 2 to base 10, we're going to put it under the placement table and multiply.
So we put this under the placement table.
Starting from the
0.
right, going to the left. So place that under the placement table. You can just put it under the number you already have. And all you do now is what? Wherever there's a 1, with the switches on, you do what? You add. Because one time any number is that number.
Oh wait, so we add these?
Yes,
together?
only the ones with the ones.
So 1, 5, 5 plus 6, 21. So 21?
You understand?
Yeah.
1 0 1 0 1 in base 2 is equal to 21.
Oh, okay. It's all about placement tables.
Correct. Yeah, knowing when to use, which one to use, etc.
Okay. I think I'll ace this time.
Okay. All right. Any other questions? No
Can you tell me
questions?
how you got 21 again real quick?
To the number, look under the placement table. You got 1 0 1 0 1. But you have to start from the right going to the left.
And you add them up?
Just add where there's a
Just
1.
the ones.
But when you go into decimal, that's when you're going to do what? That's when you do the pretty much multiplication, right? Because really, that's 16 times 1 plus 4 times 1 plus 1 times 1, right? But we know, understood 1 times whatever is that number. So you just add them.
So that one's decimal binary, octal, and that one is,
Say that again now?
which one is that one?
Right here? This
was that-
is binary to decimal.
Right. Binary to decimal. She took 1 0 1 0 1 in binary and converted it to a decimal value, which is 21.
Wait, wait.
Right. Huh?
Why did you get 10101?
No,
Give it to
it was just a given number,
Ah,
a given binary number. That's all.
And then you place it under the decimal table, because that's what you're trying.
They are the,
okay.
Binary table.
right, yeah, conversion table, correct. All right, so everybody now you ready for your quiz, right? Yes, sir.
I use a scratch paper for.
Yeah, you can use a scratch paper. What I'll do, I'll put the conversion table up so you won't need that. And if I do that, you won't need a calculator, all right? Right? All right, okay. So let's take the quiz right quick. All right, and the quiz we just converted from binary to decimal, decimal to binary, all right? Short quiz, I think we got 5 or 10 questions, all right? Let me stop this.